All right. Hopefully everyone's doing really well with this video. Today we'll be working on lesson 26, which is mathematical model of things. But really just application problems or word problems if you want a less fancier way. You're right. Um, but today we're going to kind of go. Sorry, I'm going through some headphone issues apparently. I'm just going to go through some problems similar to your homework to kind of explain it a little bit better for you. Again, as always, if you need me to, please reach out. Let me know. For starters, questions like number one, exercise A. A tinsmith wants to make a small window sensor from 20 by 60 sheet of copper. She'll form it by cutting equal size square. From each of the four corners of the sheet, full flaps to form the sides of the planter, and then soldering the four vertical edges. So basically, I want you to know like what's the maximum possible volume rounded to the nearest whole number. All right, hope y'all can hear me. Um, difficulties. There's always something. But to kind of go through this, you kind of want to think about your process here. And since we're looking for the maximum possible volume, if it helps, you've probably seen this problem a few times in your math career, but you have a sheet of uh, metal here, a Tensmith sheet of copper, where it's 20 by 60, and they're wanting to take corners out equally to maximize your volume. We just don't know how much that is. So these perfect squares are going to be x by x's all the way across. And so that means that each side, and then over here, same concept. This will now be 60 minus 2x. That would be, if I wanted to know what the volume of this equation would be, I would just have 60 x. All right. Hopefully the volume is working. I don't know what's going on. I see an indicator, but anyways, so you have one width would be 60 minus 2x. Your width would be 20 minus 2x, and then your height would just be x. So this is how you would find the volume. You're trying to find the maximum possible volume. So what we have to do is we have to figure out what this equation is, and that is, since it's going to end up being a cubic, is to be able to plug in the calculator. Had this been quadratic, we would be able to use our equations, the last sections of negative b divided by 2a, and then because really what you're doing is your maximum is going to be your vertex. It's also your minimum if you have that kind of situation as well. So for starters, I'm going to go ahead and follow this out. So I get 60 times 20, and that's going to be, let's see, it's 1200. And then 120x minus 40x, and then plus 4x squared, all that times x. Then I'm going to put this in the correct format. So this is going to be 4x squared and combine like terms at the same time. So that's 160x plus 1200 times x. Is 160x plus 4x squared x. So hopefully, yeah, good. Okay. Oops. I guess I don't know. All right, so we get this right here. Now, again, the best thing to do is then to graph this. So let me switch over. So clear the drawings. I'm gonna go to my graph here, and I'm gonna type in that equation that we just got, which was 4x. So let me hit it. Hmm. Okay. I don't know what's going on today. Um, we'll just do this. Alternative way to do it. You just hit the square first. So that's 4x cubed, and then it's minus cx squared. And then we had plus 1200x. And then was it? Actually, when you graph it, and it looks something like this. So my best advice is if you do window zoom out, so menu 4 and just hit it a couple of times. I would stop about right there. So you can see that's only getting smaller. And then I would actually go to menu trace and graph trace. You can hit left and right, move around the graph, but you're really looking for this icon that says max. So I can see the max here would be at 4.5. Just there, and you just might scroll a little bit to get max. You might think, well, there's another max. Well, not really. There's a min. Then this max here just keeps on going in. Going to be 4.51. So I'll jump back over here. I can pull it back up. And so therefore, it says again on this, what is the maximum possible volume? Round it to the nearest whole number. So if we let x equal 4 to the nearest whole number, I think I'm just going to use 4.5. 1 just because that's how I am. Because that would be like 5, and I feel like that would be too much. All right, but if we say the x is 4.5 in a sense, then we'd plug this all in. So basically, you can see this as like v of x, and then this will now become v of 4.51, and we can still use that calculator. Where'd you go? Hopefully you can still see my screen. Good. I'll delete this real quick. Won't go away forever. Then you have this number here, 2.52000. That just means move this decimal 3 places to the right. So I actually get 2520 roundabout. There you go. And so I get a volume of, oh, I got it written down over there. I get a volume of 20, got it, 2520, right? Shoot, 2520. And because this is a word problem, it'd be centimeters cubed. So the maximum cut out 4.5 centimeters here, then weld them back up and fold them, and then we have a maximum 2520. So a calculator definitely to help you solve the type here. Is the car dealership wants to try out a new leasing arrangement, which will allow a buyer to trade a car back in the dealership for a certain amount of credit at any time throughout the first 3 years of ownership. For a car in good condition, the arrangement will value the car at 1/3 the original price at the end of the 3 years and will depreciate the value of the car linearly over the course of the 3 years. So this word right here is very important because knowing that it's linear, we can produce a form of y equals mx plus b, where we'll first start off by finding our m. It's just not as clear as how do you find 3 points? Well, there's a couple of things that's presented to us. We know the value of this car is 0 is going to be whatever the price of that car is. At 3 years, the price of this car is going to be only a third of what the original price was. That's the other thing we know. Well, this is technically coordinates or ordered pair. So these are your x values, these are your y values. So I can do my change in y over my change in x. So this gives me p minus 1/3 p over 0 minus 3, and then just kind of simplify. P minus 1/3 of a p is 2/3 of a p over -3. If you divide this out, this will give you -2/9 p, because again, when you have double denominators, you can just multiply them or flip it concept. This will be what you get. So I got my m. Now I just need my b. And so to produce that, there's y, doesn't matter what is equals -2/9 p. And then my x would be 0 plus my b, which I don't know. Well, this all will zero out. So that means my b has to be p, which again, y-intercept is typically your starting value, which in this case would be the value of the car in the first place. So now I can produce an equation. So I get an equation of y equals -2/9 p plus p. And we're just going to kind of clean this. Oh, sorry, 2/9 x plus p. Keep this in a function notation. We'll say v of t for time. And so this is going to be -2/9 pt plus t. And then we're going to factor out a p to kind of clean this out. So we'll factor out a p, and then this, and I'm going to rewrite this so that I have a 1 minus 2/9 t. And so this is kind of the form they're looking for, even though this right here is completely correct as well. So now we have an equation. Now we can answer the question, what is the value of a car at the end of the first year? So now all we're going to do is plug in, see, what's the T in? We in years, which car dealership for car and condition, the arrangement of car in the 3 years, and will depreciate car linear for the 3 years. What we can do is just plug in T for years, so we'll plug in 1. So basically what we're going to do is find V1. In this case, this would be P times 1 minus 2 ninths times 1. So this would be P times, what was that, 7 ninths? So whatever the value of the car is, it'll be worth 7 ninths of its original value. And so that's kind of what they're looking for right there. So hopefully that helps a little bit more. I found that question to probably be the most challenging question y'all probably had in this assignment. If y'all understand that, relatively straightforward sense. All right, so let's look at some other examples. One is the BMI. Maybe in any. So part A here says find a model for the body mass index, which is BMI of a person, given that BMI varies directly. So if you are unfamiliar with this word directly and inversely, these are concepts in algebra, which we learned directly means to multiply, and inversely means to divide. So when I'm working this out, my BMI, and there's always a value of K of a constant number that we don't know. So we'll write K first. I think some of them use R as well, but most of the book here uses K. So we'll say K, and then it'll say varies directly as a person's weight. So that's going to be multiplied. We'll call it W for weight in pounds, and inversely, which means divide, as the square of person's height. So that I will let H be height and then squaring it. So there is your equation for BMI. With that information, they give you some more additional information so you can find out what that K is. So with additional information, a 6 foot tall, so you would need to multiply that by 12. So that would basically be 12 times 6, 72 squared. Weighing 175 pounds, our weight is in pounds, so that's going to be 175, has a BMI of 23.73. What is the BMI for a 5'6" tall weighing 140 pounds? And then there's a follow-up question after that. So we'll say, here's our K. So we'll find our K by doing some math. I'd probably highly recommend a calculator for this. I'm just going to use a little now. Let's do cross multiply. Good. Okay, good. And then so there's your answer there. Or sorry, altogether that's your answer. And then we'll divide that by 175, and we get this. Would be 702.95. And with we can then use this to answer the second part of the question. So what is the BMI if someone's 5'6"? So we'll start off with 702.95 times see 5 times 12 is 60, so that's 66. Oh, that goes on the bottom. And then weighing 140 pounds. All right. Sure. We get a B6. I don't know how accurate it needs to be. They'll probably tell you. homework. All right, there's that first part. And part B, need to have BM 22. So here, all right. I got the okay that is back on. All right, so here we go. The next type of questions you will get are things like this one, where it says a restaurantento caro frequently offers a special prefix meal and has been charging $150 per person for this event. At that price, they've been averaging 30 customers each time. Their marketing firm has convinced them that they'll gain a customer for every dollar they lower the cost of the event, and conversely, lose a customer for every dollar they raise the cost. So they fix their fixed cost per this event is $1,500, and preparing each customer meal costs an additional $20. So what are the break-even points in terms of customer serve? So first of all, you need to figure out your cost equation, which in this case will be an even 1,500 plus $20 per customer. You would then need to find your revenue cost. So the starting value of this guy is going to be $150 when there's 30 customers. But if we take a dollar for every customer we lose, that would mean that we have $180 we would charge if we had 0 customers. All right. So we will then subtract X for every customer we get. So if we had 1 customer, now it's 179, and that will get us down to, if we had 30 customers, it's 150, right? So that's kind of our number we were getting for, and we would then multiply that by the 30. So we subtract 30 to get 150, and then multiply the 30 to the 150 to find out the revenue. So this is not just straight 150X, because for every customer we get, we are subtracting and or adding to the cost of this guy. So 180 is the maximum price we can do per person, and for every customer we get, it just goes down $1. Now, the next thing you need to do is be able to do profit, and profit is raised from revenue minus cost. So this is going to be revenue minus cost. So in this case, I would do, I'm gonna go ahead and kind of pull this out. So this will be negative x squared plus 180x minus, I'm going to distribute that negative to all of that. So that'd be 20x minus 1500. If we simplify that a little bit further, that gives us negative x squared plus 160x minus 1500. So there's our equation. If we want to break even, what that means is we want to have $0. We don't want to have a profit. We don't want to have a loss. So we'll set this equal to 0. All right. Best way to do this is kind of solve it. I don't like dealing with negatives. So the first thing I'm actually going to do is multiply everything by a negative. So that'd give me 0 equals x squared minus 160x plus 1500, but it really doesn't matter. I want to solve it using the x because I'm trying to find out how many customers served. So that's going to be x equals negative b divided by 2a. So remember, my a is 1, my b is negative 160 now, and my c is 1500. If you kept it the same, and the signs would just be different. So this would be 160 because that's what negative 160 is. And then this would be 2 times a, which is just 2. So 160 divided by 2 is 80. So my break even here oh man, my bad. That would give us our maximum profit. Break even, I want to have $0 because if I put 80 in there, yeah, hold on. Let's make sure, let's verify that. So that would give me, yeah, I looked, I got the maximum profit. So you need 80 customers to make the maximum profit. Not what we want to do. We want to do break even. We want to factor or use the quadratic formula. Oh man. Multiplies to 1500 and add to negative 160. I don't know. So I'm going to go with negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this case, that'd be negative 160, which is positive 160, plus or minus the square root of negative 160 squared minus 4 times 1 times 1500. And then that would be 2 times 1. All right, so we get 160 plus or minus the square roots. All right, so in this one, let us do 160 times 160. And we're going to do that minus 4 times 1500. Well, 2 times would be 3,000, so that would be 6,000. We get 1960, the square root of that result. Oh, good, it's a nice clean number. So this would be 19 over 2, which gives us 160 plus or minus 140 over 2. So I can do 160 plus 140 divided by 2. Oh, it's not even typing. Let's try that again. So that's 160 plus 140 divided by 2, which is 230. And then the other way would be, so let's write, I need to write that down. So 230. And then we'll do 160 minus 140. Divide that by 2 is 10. So we can do 10 or we can do 230 customers would basically be break even. So if we do $10 or 10 people, we'll walk away with $0. And if we go to 230, we would then hit break even. So what that means is if we go over 230, now we're in the negatives. So that the profit range is between 10 or 230 customers served. All righty. All right, let's see. So let's see if there's another type. I think there is. Oh, yeah. There's like these next two are pretty much the same. You're given a table and you're asked to find linear and quadratic. So I'm going to reference to page 17, but I'm going to be in the calculator. So what I'm going to do, just like last time, I'm going to go to list and spreadsheets. I want to make sure that's my X, make sure that's my Y. If you still have the previous work or other work in it, make sure you get a new document so you have fresh information. You're not pulling from old. That's a 0, 0 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 200s, 196, 184, 164, 136, 156. Again, make sure you arrow out. I'll go back home. I'll go to data and statistics, hit my X here, hit my Y here, and this is what my graph looks like. Now, part B and C, part B says find a linear function. So again, that would just be menu, analyze, regression, and then I'm going to show linear. There's two different ones. There's mx plus b and ax plus bx, or a plus bx. We use mx plus b, so I'm going to do one. There's my equation. So when I come back over here, I will write that down. So for part B, I got y equals, I wrote it down earlier, negative 48x plus 220. The following question after that, it says, what is the, so by the linear model, what is the extrapolated time when the rock hits the water? So basically, when will it hit the water? So you can kind of come over here, take that equation, and you're trying to figure out at what time. So to do that, just go back to graph, and you'll type that equation in. So that's negative 48x plus 220. And then just do menu, trace, graph trace, and you're just trying to find the x-intercept. And it looks like about 4.58 seconds because the t or x is in seconds. So if we bounce back, again, that would be 4.58 seconds is how long it would take for it to hit the water. And then it says, what is the calculate linear model height of the rock at t equals 0? So if I just plug in 0 here, I would get x equals 220. Or sorry, not x, it'd be y. Y would equal 220 feet. And then it asks you basically to do this again, but with a quadratic. So I'll bounce back. I don't got to do anything extra, but go back to that data and statistics. I'll then do menu, analyze, regression, and now I want to show a quadratic. So there's that. So I'm going to write that down. And I wrote that down earlier as well. So we're going to have to go back and forth. So that'd be y equals negative 16x squared plus 200. Do the same process. When would it hit the ground? So I come back over here. I'll do a new graph. Would be nice. New graph. And then so I'll type that equation in, which I wrote down, negative 16x squared plus 200. And then obviously I have a negative and a positive. I'm going to want the positive. So I'll do menu, trace, and then I'm just going to go find the x-intercept on the right side on the positive axis. And it looks like it's about 3.54 seconds. And then my y would be at what value of time is 0, and that's going to be 200. So this is seconds, this is feet. And so what it's basically asking you is which one of these functions on the homework will ask you which one's a realistic one. And kind of looking at this, it looks more quadratic, mainly because of the curve, but also since the y-intercept actually is at 200 versus 20 feet off. So I would say a quadratic is a better model. All right, I think I got time for one more before I gotta move on to my next task. So let's look at this next problem. It's very similar to what we just did. It's just talking about Karen bought a puppy and has been tracking its weight at the end of each month since it was born. She was told the dog's breeder that the dog should have an adult weight somewhere between 40 and 45. So these are going by months and then the pounds each month. And it wants us to do the same thing. So I'll show you all one more time. So again, what I'm going to do this go around is I'm going to do a new document and I'm not going to say so it's nice and fresh. So notice I have no more tabs here. So I'm going to accidentally pull data from a different set of data. And then again, I'm referencing question 18. So I'm just going to go down the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then move over here. And I would have 3, 5, 8, 11, 17, 22, 28, 32, 35, 38, 40, and 42. Again, don't forget to arrow out. So then I go home, I go back to data and statistics, X, Y, and then I'm going to try to do a linear. So that's going to be 4. I don't know what just happened here. Oh, well, whatever. So menu, 4, 6, 1. Oh, good, it went away. So there's my information there. I'm going to round to about 2 decimal places. So my Y would equal about 3.93x minus 2.15. Ask the same thing. What is the approximate? This was a little different. What is the weight at the end of the second year? So that's going to be in 24. So all you got to do is plug in a 24 there. So I'll just use a calculator. That seems to be a little bit easier. So 3.93 pounds per month times 24. And then it started at negative 2.15 pounds. So in 2 years, this dog would be 92.17 pounds. I would say that's unrealistic because it did say that the adult is between 40 and 45. So I would say an unrealistic result. And then do the same thing with the quadratic. So I'll do this one more time for you. So again, that's going to be menu, analyze, regression. This time I'm going to do quadratic. And then there's my new equation. You can always drag it if you need to see it better. Oh, I did not choose the wrong one. The right one. So that's 4. Dang, what's going on? 4, 6. Where's quadratic? Or I put quartic. Quadratic is 4. Not bad. There it is. That's the right one. And again, I'm going to round to 2 decimal places. So when I do this, I will get y equals negative 0.08x squared. It's supposed to be a 2. Plus 4.93x minus 4.48. Again, I'm just going to plug in 24 real quick. Find that to be a little bit quicker maybe. So it's going to be 24 times 24 times 0.08. I'm going to make that a negative. And then I'll add that to 4.93 times 24, and then minus 4.48. And in 24 months, he should be about 67.76 pounds. So a little bit closer, my opinion, still not realistic. Because again, he's supposed to be between 40 and 45. All right, so again, if there's any more questions that you need me to go over, feel free to ask. Hopefully the speaker worked the entire time. There might be some little ins and out, but I think I finally got it working there about halfway through. All right, see you on the next one.